let's look at how to use the first law of thermodynamics for constant temperature processes. And these are called isothermal. So the first law of thermodynamics says that change in internal energy depends on the heat transferred and the work done in the process. We know that du can be defined as, or can be determined as NCV dt. However, if delta T equals 0, then delta U also equals 0. So there is no change in internal energy for an ideal gas if it is in an isothermal process. So this tells us then that the heat transfer is equal to negative delta W in this case, and we know that the work can be defined as negative PdV. I have two negative signs in here because I already had one negative sign to begin with, and then I defined work as negative PdV. So we have delta Q equals negative delta W equals PdV. We can use the ideal gas law here and say that P is equal to nRT divided by V, which gives us delta Q equals negative delta W equals nRT divided by V dV. Now we're going to integrate all of these. And N is a constant, it's the number of moles in our system. R is a constant, it's the gas constant. T is a constant in this case because we're saying it's an isothermal process. So all of these things can essentially come outside of the integral, which makes this an easy integral to do. And we end up with Q is equal to the negative of W is equal to nRT times ln of V2 over V1. So in an isothermal process, we use this equation here at the bottom to calculate both the heat transferred and the work done. And we remember that delta U equals 0, and that allows us to find everything we need to know for the first law for an isothermal process.